Assalamualaikum and very good morning. So we continue for our topic for the chapter 1, 1.2 regarding for the limits and continuity of the several variable function. Okay, so before we proceed for the function of the several variable, function of the multi-variable, so let's we recall back what is the limits. Okay, what is the limit for the single variable, okay, ataupun single independent variable for the single function. So let's say we have the limits okay, x approach to a, fx equal to l. Okay, so how we can know that the limit is exists or not exist? Okay, how we can determine based on this single variable function? Okay, so for the single variable function, so we can call the limits is the exist when the I change the colors. Okay, when you found the function, let's say you have the function here and at the x-axis, okay, x-axis at a certain point here, okay, certain point here in the axis x. So that point when the curve that have the two direction from the left to right, right to the left, okay, they have two direction, and then the meet at a certain point. When the meet at a certain point, so x ni the limits, the meet at a certain point from the left curve, the move along this curve, okay, the move along the curve and met here. So this one we call as the limit exists. Okay, limit exists. Okay, so how about doesn't exist? So for the doesn't exist, that say the curve, the function have the function left side and right side, and at a certain point in the x-axis, okay, the point doesn't meet up. Okay, it doesn't meet up from the curve at the left to right side and right to the left side. So this one we call as the limit doesn't exist. Okay, the limit doesn't exist. Okay, this one we call back. We call back for the chapter 1 regarding for the limits. Okay, this is the single variable function. The direction only they have the two way. Okay, only they have two way, from left to right side, right to the left side. They have only two way. So this is simple. So we can directly found that the limit exists or not exists. Okay, how about when the limit in the several function? Okay, what about limit for the several function f x y equal l, and x y it approach to a or b at the point a and b. So how about for the several function? Okay, for the single function, easy, they have two direction, left to right side. But for the several, okay, this one is the two independent variable, so they have the x-axis and y-axis. So how many paths to meet that point? Okay, to meet that the point, that certain point. Okay, so for the several or two independent variable, that means we have the surface that are do path along the surface that approach the point. Kalau for the single, we have the line curve, we have the curve. But for the two independent variable, we have surface. Let's say the example we sketch the sphere lah, sphere yang paling mudah lah. To make sense, we sketch the sphere. Oh, color pen, color. Okay, I sketch the sphere. So let's say, okay, you have this one. Okay, sphere here. Okay, the example you have the sphere. So they move along surface x and x and y, x and y. So how we can determine either the function exists at this point. Okay, this point. Let's say this point x and y dia ni z, ni y, ni x. So let's say the x s y dia dekat sini point ni. Let's say x s y dia 1, negative 2. Let's say lah. Okay, 1, negative 2. How we know the function of this one, the function of here is exist or doesn't exist? Okay, kalau single senang, they meet at a certain point, so we know they exist. Doesn't meet is not exist. So the path in the surface, how many direction? For the single function, we only have the two direction, right to left, left to right. But for the two independent variable, so the direction can be here. Okay, can be here. Okay, can be here, can be here, can be here, can be here. So they have many paths. So how we can prove that the limit doesn't exist? Okay, to prove that the limit exists, easy, because they have the many paths. Where is the path has the meet at the same point, so we can call it the limit is the exist. So how we can determine whether the limit is the doesn't exist? Okay, in the definition, so we can prove that the limit doesn't exist by showing that along two paths we get a different value as we approach the same point. Okay, so we have the same point. Let's say we want to approach this point, but the value for this path and this path is not same. Okay, so this is the definition. This is the definition of the limit in the several variable function. Okay, so in the words, okay, in the words we can call, okay, the limit exists when the point defined or not defined. Okay, first attempt we determine the function can be defined or not defined. If defined, okay, if we define. If not, if defined, this one we know that point and that point. What is the definition? If not, we try to simplify and check for the new f. Okay, can define or not. Okay, if not, we try for the third attempt. The limit doesn't exist. Show that the limit does not exist by choosing the any smooth curve we pass to that point. This is the definition. Okay, how we can prove that the limit exists or not exist. Okay, so usually in the several variable function, we always ask for the show that the limit doesn't exist. To show the limit exists is simple because they have the many paths to meet that the same, to approach to the same point. Usually in our courses, we always ask show, prove that the limit doesn't exist. Okay. Okay, let's say we have the function. Okay, they're given the limits. They're given the limit. Limit x, sorry, x, y. Okay, approach to 0, 0. X kuasa 2 minus y power of 2. 2x square plus y square. So prove that limit doesn't exist. Okay, so the first step, okay, the first step, okay, the first step, we need to choose along x equal to 0. Along x equal to 0. So along x equal to 0, you just substitute x equal to 0 into the function. So x jadi tinggal negatif y kuasa 2 plus y kuasa 2. Sini jadi kosong, kosong. So y kuasa 2 kosong, you dapat negatif 1. And the second one, you choose for the another path. Okay, you choose for the another path. along y equal to 0. Y equal to 0. Okay, that's point. Okay, so along y equal to 0. So y0, so you remain for the x square, 2x square, simplify, so the answer is the 1/2. Okay, so the definition that said the limit doesn't exist. Limit doesn't exist by showing that along two paths we get different value as we approach the same point. Okay, so you prove that two paths different value. Okay, two paths different value, you show that the two paths different value, so that means is we can call as the limit doesn't exist. Two paths, one along x equal 0, second path is the along y equal 0, and the answer is not same. That means limit does not exist. Okay, that's the way. Okay, so I can write down this simplify. I can simplify how you can solve for the limit, how you can determine the limit is the doesn't exist. So the first step, kali lain okay, the first step, try along, okay, x equals 0 and y equal 0 path. Okay, equal 0 is depend on the approach point here. Okay, so that's the first step. A second step, okay, if the answer you choose this one, if the answer same, let's say the negative 1 here pun negative 1, when the value is the same, so the is can define as the limit is the exist, but the question asks to prove that the limit doesn't exist, so you need to try for the next step. Okay, the next step, okay, so the second, you certain point, second is you substitute, try to substitute any value here. Okay, substitute here x or y to make sure, so degrees of numerator, degree of here yang atas ni equal to denominator, numerator and denominator. Okay, so let's say this one power of 2, okay lah, power of 2, okay, no problem. Let's say this one, the numerator power of 1, denominator power of 2, so you try to substitute the x or y to make sure the degree is the same. Okay, so let's say, okay, this is the first and second step. So let's say we try for the another example. The given is the limits as y approach to 0, 0, 3xy equal 3x plus y square. Okay, proof limit does not exist. Okay, first step, we choose along x equal 0, y equal 0, along x equal 0, along y equal 0. So the 0, 0, 0, 0 divide by something, 0 divide by y kuasa 2, so 0, 0 divide by 3x square, 0. So the value is same. So when the value is same, that means the limit exists, but the question asks to prove that it doesn't exist. So you need to try for the second step. So the second step, you need to find, to make sure the denominator, degrees of denominator and numerator is the same. Okay, kalau here this one, I try to make sure the degrees to be a 2, degree 2. So I change x, y equal to x. Okay, along y equal to x. Okay, y dia akan jadi x, so dia 3x multiply x, 3x square plus x square. So the given 3x square plus 3 plus 1, 4x square. So you multiply, you akan get the answer 3 over 4. When the answer is 3, 4 not equal dengan atas ni, so this is proof that your limit does not exist. So this is the way. Okay, you substitute the variable to make sure the degrees have the same 2, 2. They have the same degree 2, 2. So you can simplify and then you get the answer. That's the way how you can solve to prove that the limit doesn't exist. How about if the question have the 3 independent variable? Okay, they have the 3 independent variable. So instead you use the similar method as the 2 independent variable, you also can solve for the 3 independent variable by using this step. Okay, let's say the given the limits okay, let's say the given the limit. Okay, they given the limit 3. So you can use similar as the previous, or you can change the function become as a parametric equation. Okay, let's say the given the 3 dimension, 3 independent variable. So the given limits, okay, x, y, z opposed to 0, 0, 0. The given xy plus yz, okay, plus xz, x square plus y square plus z square. So prove that the limit does not exist. So if the question given the 3 independent variable, instead you use the same method as the 2 independent variable, you can also change the function to the parametric equation. Okay, so you change in the parametric equation. So parametric all become as the t, all the variable become as the t. Okay, so the first change in the parametric equation. Second, second, always choose an axis as first part. Okay, so choose an axis. So we can choose either x, y or z. Okay, x axis, y axis or z. So commonly we can choose on the x axis. When on the x axis, so that means y and z equal to 0. Okay, and x axis, so the example, so this one z, this one y, this one x. So along x axis, that means that's point along x axis, axis y paksi x yang kita letak kat sini. So along here, z is equal to 0, y equal to 0. Okay, that's the mean. So always choose x-axis as the first path. Selalunya kita akan choose x-axis lah. So along x-axis, that means y equal 0 and z equal to 0. Substitute here, y equal 0, z equal 0, 0, 0, 0. So yang ditinggal, you limit x dia opposed to 0. Opposed to 0, yang tinggal adalah kosong, x kuasa 2. So kosong bagi sama dengan kosong. Okay, this is the first path. Okay, second path, you can change the equation to the parametric. So how we can change? So let's say we write x equal to t. Okay, because the degree of 2, we make sure numerator and denominator have the same degree. So when you want to substitute t, make sure numerator and denominator have the same degree. So here 2, so atas ni 2b as the 2, so you make sure t multiply t. Okay, so all x equal t, y equal t, and z equal t. So when you choose t here, so that means both have the same degree. Numerator and denominator have the same degree. Okay, so this one is t square plus t square plus t square, t square plus t square plus t square. Okay, this one t multiply t square, t multiply t square, t square. So 3t square, 3t square. So multiply, simplify. So you dapat 1 and 0 is not same value. So you already prove that the limit does not exist. Okay, that's the way how you can solve for how you can prove that the limit doesn't exist for the several variable function. Okay, so we proceed for the next topic is the continuity. Dalam bahasa the British accent, continuity. Okay, so the first step, you must be define that the function at the point AB or ABC. Okay, the second one, you limit that function. Okay, the limit that function is exist, and then you compare both. You compare number 1 and 2. If the 1 and 2 equal, so that means the function is the continuity. If the number 1 and number 2 not equal, so that means the function does not continuity. Okay, this is the way, simple, very simple. So let we do the example. Okay, determine whether the function continuous. Okay, the given the function f x y equal 2xy x square plus y square. So this one, the given must be x square plus y square not equal to 0 for this function. The second, the given fxy equal to 0 and x equal y equal to 0. So they become 0 when the x and y equal to 0. Okay, xy ni atas ni lah. Bila x and y become to 0, so the function become to 0. So the first step, you need to determine whether the function of the continuous at 0, 0. So point ni you kena look at the point mana they want to prove that the function is the continuity or not continuity. So the first step, f, so xy dia point here. So you kena masukkan kosong-kosong lah. Kosong-kosong. When you substitute kosong-kosong here, kosong-kosong-kosong-kosong, so you dapat 2 kosong 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 kuasa 2, kosong kuasa 2, so equal to. So the second one, you limit x, y opposed to 0, 0. Okay, opposed to 0, 0. First, define. This one define. And then second one, you must be limit. Okay, you limit 2xy kuasa 2 kuasa 2. So when you limit 0 over 0, so equal to 0. So this one exists. So when you compare nombor 1, nombor 2, so the answer is the same, kosong equal to kosong. So the function is continuity. If the answer not same, the function is not continuity. That's all how you can prove that the function is the continuity or not continuity. Okay, simple, simple, very simple. Just follow the step. Okay, I left you some example here. Okay, I left you some exercise. Okay, try to solve this one. Okay, the given the sama, determine whether the function continues. F x y, okay, x square minus y square minus 1, 4x square plus y square plus 2. Okay, this one, and the x y not equal to 0, 0. Okay, nombor second dia kata 1 over 2 when the x and y equal to 0, 0. Okay, so prove that determine whether this function is continuous or not continuous at 0, 0. Okay, that's all for the class today, and we meet you for the next class. Thank you.